So we use this calculation.
Sorry.
Oh, got it. It's being recorded. So using the tree height and diameter that you've measured, we then go about calculating the tiny forest carbon that's stored. And we do this by initially calculating the green weight, which is, we use a mathematical constant, that's just about unit conversion, which is then multiplied by tree height and then multiplied by the tree diameter. We then take this green weight and half it, because to calculate the dry weight. So this is basically when, if you imagine that all the water has been sucked out of a tree, it's approximately half the weight of a green weight tree. And then from then, it's very simple, we then calculate the carbon storage as being half of what the dry weight is. So we calculate the green weight by the measurements you've given us, then just halve it to find out the dry weight, and then you halve it again to find out the approximate amount of carbon that's stored. And through experimental sort of research, that's found to be an approximately right when they've actually taken trees out of the ground and weighed them. And then when we look to scale this, so this is per tree that we calculate this, and then to scale it for each of your tiny forests, we take the mean amount of carbon that's been calculated from each of those 1 to 100 tagged trees, and then we times it by 600 to scale it to the size of each tiny forest, because it's 600 trees approximately in each tiny forest. And when we've done this for 2022, we found that there's approximately 2.4 tons of carbon stored across 149 forests. And this is equivalent to around a quarter of a person's UK annual footprint of carbon. So we appreciate that obviously this isn't the Amazon rainforest. This sounds like a relatively small amount of carbon, but you've also got to recognise that at the moment, the tiny forests are very small. You know, most forests will exist for hundreds and hundreds of years until they're basically cut down. We're only on year 2, and the way that forests grow is it's not necessarily what's called linear, so it's not in a straight line. They'll kind of wiggle in terms of how fast they grow, and the first few years is actually quite slow, and that also results in how much carbon is stored, equates to the amount of above ground biomass and how much they grow. So so we don't have currently, that doesn't sound like a lot, but also the climate crisis and the amount of carbon that's stored in trees is generally a cumulative effort. You know, this is the reason why the UK government is giving free trees away to each individual that lives in the UK. Every little helps. We're not saying we're going to solve the climate crisis through tiny forests, but we will certainly contribute towards it. And as Daniel's mentioned, we're not planting in a conventional way, we're planting in a much more dense way. And there has been claims around Miyawaki style planted forests storing much more carbon in a smaller space than a standard conventionally forest, but there's no science to support this. So what we're really doing here, and we really need this continual monitoring by yourselves to help us understand over time, is there sorry, do tiny forests store a much denser amount of carbon because we have more trees? So hopefully over sort of a long term, this is a long-term experiment, we'll be able to answer that, and ultimately we'll also be able to help contribute in our own way towards the climate crisis. So, and one of the ways that we have been doing that is obviously we have been able to monitor the tiny forest carbon is through measuring the tree growth rate, and the tree growth rate also tells us really interesting things about how, for example, this planting style differs and is unusual, but it also informs us on, as I said, how, for example, carbon storage sort of changes throughout the life cycle as a forest. So as I mentioned, forests don't grow in sort of a consistent rate. You know, they'll kind of wiggle and waggle about how much they grow, and that's true in terms of their carbon storage as well. So what you can see here is over the course of last year, just over 4,000 trees were measured and 49 species. But you can see here that our different canopy layers grow at a different rate to one another. So the sub-canopy and the understory were quite slow, and then they've had a really big growth rate in that find that last year. So and that's really interesting, and that also means they'll have stored carbon a lot more in that year as well. And you can see unusually that canopy, which is usually our tallest trees, have grown quite slowly in comparison and are currently smaller than the subcanopy and understory trees. But we'd expect this. So canopy trees tend to be much bigger and they tend to live for much longer. So for example, up to sort of 400 years for some of our trees, but they tend to grow slower, and then they'll tend to have sort of bigger growth spurts at certain times compared to others, while the subcanopy trees really get themselves established. So we can see that here about the fact that sort of the different growth rates we get, and it's really interesting for us to understand how that might vary depending on climatic factors about where we are in the UK and how that might affect our carbon storage. But what's really interesting is when you stack all of our trees on top of each other, it's still huge. They total 7.5 Mount Everest when they're all stacked on top of one another. So as I said, in terms of the amount of trees that we've got and the carbon storage, it's not insignificant, and it's really interesting research that nobody else has, and it's all thanks to you. And finally, some take-home messages from our sort of tree champions, as it were. So from the tree measurements that you've given us, we've been able to establish which are our biggest trees, which are our smallest trees at the moment, and how they change with growth. And here you can see goat willow, which is also known as a pussy willow. The biggest ones we have of those are over 4 meters tall, and they understandably also have the thickest stems. And our smallest trees are the English oaks and blackthorn, or slow bushes, and they're in our sort of youngest forests. And what's I thought as a side for you to have a look at if you're going to your tiny forest at the moment, some certain trees are starting for flower. So on the right you can see actually goat willow flowers. So goat willow puts out these what are called catkins. Their flowers are called catkins. They're quite unusual structures, and goat willow trees are actually have separate sexes. So on the left you will see the male part of the goat willow catkins. These are these fluffy male flowers, and on the right are the female catkins, and you'll find them on different trees, and they're really, really important to pollinators at this time of year. And then on the bottom, you can see the blackthorn flowers, which are these really beautiful clusters of white flowers that are out there at the moment. So if you want to sort of go out there in spring and start recognizing these trees, this is a good way. And also pay attention to what pollinators are around, because these are fantastic food sources at this time of year. And now I'll pass on to Daniel. He'll be talking to you about flood management.
Thanks, Sophie. I'm going to whip through these the flood management topic. I'm going to, because we've taken more time on the other two. So in terms of flood management, urban areas suffer from issues because of the lack of permeability of the ground in urban areas. So you end up with a lot more issues with types of flooding that we've seen in the news due to ground and increased ground runoff. So tiny forests are really interested in understanding how the forest itself, how the presence of the trees, and how the soil preparation that we do when we plant a tiny forest can impact on how well they do in terms of managing these extreme events. So I won't go into the detail of that right now. We understand that the trees play a role in terms of stopping the water reaching the ground and slowing down the flow of water. But the bit that we look at in our research is mainly about the soils, and it's where kids like these have really enjoyed, and hopefully the adults too, getting their hands muddy and getting involved in understanding the soils in our tiny forests in and around them. So 303 infiltration surveys have been submitted. The infiltration survey is a survey where we measure how long it takes for water to flow, a set amount of water to flow into the soil. We conduct this survey inside and outside the forest. So at the moment, in these early stages of the forest, we're really looking at the difference of that soil preparation technique to understand how that has improved conditions, both for the trees and for the local environment. So we measure the amount of time it takes, so the rate at which the water infiltrates into the soil. And when we took these surveys from outside the forest, it took about 3 minutes and 31 seconds for the water to infiltrate into the soil outside the forest, whereas inside the forest it's taking only 2 minutes 24 seconds. So this gives us a 32% faster rate of water being absorbed into the soil. And this, you know, it's really good that we can record this even at this stage, and this is part of the soil preparation techniques and the addition of the supplements when we prepared for the forest to be planted. But it also gives us a really good starting point and baseline to understand now, as the trees develop and the roots play their role and the invertebrates play their role in breaking the soil up, and as the leaves fall and that process continues, that hopefully we'll be able to see this gap between the two increasing even further as infiltration improves, and the ability of the forest to suck up water really shows the difference between where our trees are planted and where the original conditions were. It's really important with our surveys we get people to understand the types of soil that they're actually working with, because obviously different types of soil just have different physical characteristics. So this diagram shows you about the percentage of different types of soil: the clay soils, the silty soils, and the sandy soils. And basically you're seeing where you have more sand, more larger particles, the water can flow through the soil more easily than where you have more clay at the top of the peak of the diagram, where the clay particles are very, very small and stick together really hard, and you can imagine less water flows through the soil. So we have to understand, in order to understand the infiltration data, we have to understand what type of soil the test was taken in, and it's really evident that in those soils, so this is now showing you the infiltration time for forests that were planted in sandy soils and those in clayey soils. And the green bar is the outside the forest time, and the inside the forest is the orange bar. So on this left-hand side, the sandy soils, you see a really dramatic improvement in the infiltration rate for the sandy soils. It gets faster because we've improved the condition of the soil in the preparation, whereas in the clay soils there's less of a difference at this early stage between inside and outside the forest. But in sandy soils you get up to almost 50% faster infiltration before, like inside and outside, before and after. So this is all going to help us understand more about how it improves over time. Caroline.
I'm a bit puzzled by that, because I would have thought the addition of organic matter to a sand soil would actually slow the water, because sandy soil drains so freely anyway, and it would go the other way. What's going on, do you think?
I think that's really interesting as well, and I think there's the next slide we talk about compaction, and I think that's going to play a large role in what we're seeing here, because compaction, how hard the soil is, obviously has an impact on how well the water can flow through it as well. So at the moment, this is just looking purely the conditions outside the forest and inside the forest to do with the soil preparation we've done. But what we need to understand that better is to understand the compaction of both those two areas as well. So if I'll just go on to the next slide, we get people to measure how compact the soil is, and we do this for both reasons that you're saying, as you're mentioning, around the water flowing into the soil, but also because the compaction has an impact. Compaction affects the root growth of the trees. So this is also another reason why we do the soil preparation for each forest, to allow the roots to penetrate the soil more easily. So inside the forest, our level of compaction is much lower now than outside the forest, as you would expect, because we've dug the soil up and we've done all the preparation. So it should be softer, it should be easier for the roots to grow through, but also for the water to infiltrate through. So I suspect that's what we're seeing, Caroline, with the sandy soils, is that inside the forest, we've dug it all up, we've churned it up. So even though it's a sandy soil outside the forest, it's so compacted that the water's flowing off the surface rather than flowing through it.
I think the organic,
and as I say,
the organic matter will probably help to kind of provide some like structure and create pore space, which also further contributes. Like so when it's been to that question as well.
Yeah, that's a really good point. So it's to do with the root, the water infiltrating through, but it's also to do with the root growth. So these sort of thresholds that are used in kind of our decision making about how and where to excavate the soil and what supplements are needed. If this is megapascals, which is the measure of pressure when we measure the compaction of the soil before we plant the forest, and if it's under 1.5 megapascals, it's considered there's no problem for roots to grow through it. And as you go up in pressure in terms of soil compaction, that's when you start it. When you get above 3 megapascals, that's when you get root inhibition, like actually stop, the roots can't get through it. When you're in the orange zone, they can have a bit of an impact, it can hold them back a bit, but basically you're wanting it under 2 megapascals. So you can see that inside the forest we're now mostly getting into the good zone, and a few of them are still up in the top, whereas outside the forest obviously we're still in this zone where if you just planted trees in that field without doing any of the soil preparation, you could have risked the longevity of those trees and the growth rates. And you do see that in urban tree planting. It is a really considerable problem that trees are planted without any soil preparation and they don't survive well. They're not able to root, and then when the next big storm comes, they haven't got the strength to hold themselves. So that's just a really whistle-stop talk. I'm really conscious of the time, Sophie. We're gonna have to go through thermal comfort quickly and then give people time for questions.
Yeah, I'm sorry, that was probably my fault for waffling on for too long around carbon, because it's just such a complex topic. So thermal comfort refers to obviously how comfortable you feel within yourself temperature wise. The way we measure this is both through actual weather data from the weather stations that you can see in these photos here, and also asking people how they feel. So last year we did over 4,000 measurements, and we haven't really been able to answer our research questions yet, because thermal comfort very much depends on having a much more mature forest, tiny forest, right above your head with canopies of leaves. But the two questions that we hope in time we'll be able to answer is that, do tiny forests have a cooling effect in what are increasingly hot cities? And do the local microclimate conditions differ inside the tiny forest compared to its maybe outside urban surroundings, so near to grey infrastructure, roads, buildings, etc.? And how do people perceive this in terms of how they feel thermally, so how in terms of their thermal comfort. So as I mentioned, we haven't yet been able to really draw any clear conclusions, and that is because most of our tiny forests are still quite small, as you're aware. Most cities, so I'll just talk you through what we expect to see. Most cities are due to be up to 10 centigrade higher than surrounding rural areas in sort of now, especially last year, and in forthcoming years due to climate change. And this heat difference is due to something called the urban heat island effect. So basically all the concrete and hard infrastructure, lack of plants, basically means that cities are really a heat trap. And trees can really help to mitigate this incredibly substantially. So trees can mitigate the urban heat island effect by providing shade, and also something known as transpiration. So tree leaves contain these tiny little holes called stomata all over their leaves, these little holes, and those holes are actually more like mouths. They open and close in response to different triggers. So I'm a plant scientist. I did a lot of work on stomata, and they open and close in response to light and also water availability within the plant. So what plant canopies do is they take in carbon dioxide and then they release water as a byproduct, and this transpiration of water is a real key cooling effect. So you can see the top right image is taken from a laboratory in Australia, and this is during a Melbourne heat wave. And using a thermal imaging camera, you can see that where the trees are is nearly half the temperature of that external temperature of the concrete outside it, which is massively huge. And then the bottom image is one of the tiny forests by IVN, I think, in Utrecht. And you can see here that the tiny forest itself is this quite blue colour, which indicates that it's cooler, and then the trees and the grass around it is much hotter. And this reflects what's seen in the literature. So a recent study that was across Europe, so 290 cities across Europe. So this is this literature reference at the bottom if you want to find it. But 10 of those cities were in the UK, and they found that in UK cities, trees can actually cool by 11 degrees Celsius, which is massive. It's a really big difference. And what's really interesting is that actually this cooling effect is higher further north in Europe because there's more water availability in the soil. So the stomata are open more, so they're releasing more water. Whereas actually down towards the Mediterranean, this effect is less because the plants have their stomata closed because they can't afford to lose water in hot conditions, which is super interesting. And there's lots of other sorry, I've got a dog nose in my face. There's lots of other psychosomatic, so the space of being present in a tiny forest or in a forest, just the presence can help you kind of psychologically think that you feel cooler. And we think that we saw this in our oldest tiny forest at Whitney, where the weather station data didn't say that it was particularly cooler compared to outside, but all of our participants said they felt cooler inside a tiny forest and when stood near to buildings. So that's where we think we're starting to see that sort of psychosomatic effect of being present near trees. So yeah, it'll be really interesting to see what happens once these trees get much bigger. It's a really exciting area.
Thanks, Sophie. Bringing us to our final topic around the social impact, we really wanted to understand how the social reach of tiny forest, how effective we are at engaging a diverse range of people in the forest, and in doing so, we've been able to map out the forests that were planted by summer 2020 in relation to what's called an index of multiple deprivation. As government sort of statistics that allow various factors, including health and employment and housing and green environment. And we as an organisation are aiming to plant more forests in areas of multiple deprivation because these areas have also limited access to green space. So this is where we feel that things like a tiny forest will have a greater impact. And this is in line with the government's 25-year environment plan, which is seeking to reconnect people with nature and trying to improve the conditions in our cities. So we know that it's not felt equally currently. So it's really important for us to understand what types of communities, what types of areas of our cities we are already working in. At the moment, 50% of tiny forests in England, this metric currently is available for England. There's a slightly different metric for Scotland, so we will have that for the whole of the UK at some point. But 50% of our tiny forests in England are planted in areas of high deprivation. And 63 of them are in the most deprived 30%. So we are hitting some of our target areas, and that's going to be important as a background to understanding, for future social research. And we also want to understand the type of people that are coming along to our events. And the most common demographic is fairly common with quite a lot of environmental projects in terms of being largely white, female, and aged between 25 and 44. The majority of people with a sort of degree or college education. But in terms of ethnicity, some of our sort of groups that are involved shows a bit more diversity than the national population. 26% of people in our survey identifying as Black, Asian, or minority and ethnic groups, compared to 15% as a nation. So this is very much a first step, and we've got a relatively small sample size of the people that we've been able to gather these data from, but I think it's really important for us to understand and make sure that we are making our activities and our forest accessible to people and trying to remove some of those barriers. We mentioned right at the start that we are trying to understand people's connection to nature and how spending time in nature makes them feel. So we've got some really nice results, as I say, from these initial pilot studies where we have a relatively small sample size of people responding to feeling calm and relaxed, saying that it made 93% people saying they felt refreshed and revitalized. Felt that they were close to nature. And we also measure using a standardized score for nature relatedness, which gives us a score greater than 3, showing that people already have quite a strong connection to nature, which is related to how much you are likely to act to protect it. So in time, we want to understand how that changes as people spend more time and take part in more activities in the tiny forest. And we want to try and get these data from a before and after sample of people who, to really understand how the impact of being involved affects people and their perception of nature and how important it is to them in their life. So that's the end of the research section. I'm sorry we've overrun. I'm just going to leave this slide up briefly, just say there's many more avenues of research that we are exploring in our team and in research with research connections with universities. We're leading I'm going to be leading a Miyawaki research network, and we're gathering other practitioners and researchers from across the country and across indeed Europe and now as far as Canada at the moment. But please do keep an eye on the website for the future research sort of outputs, taking part in publications and conferences, and any of you with more interest in the science, please just come and speak to us at any point. You'd be very, very welcome to if you want to learn more. So finally with Sophie for what's next, just briefly, and then any chance for questions.
Yeah, so we've got some upcoming planting days. If there's anything nearby, have a look at Earthwatch's Europe's Eventbrite. So they've got ones in Edinburgh, London, Darlington, Castleton, and some other ones coming up. If you would love to get involved, we'd love you to get involved with monitoring your tiny forest over the forthcoming year, because the more of this information we have, 1, it engages people with their tiny forest, and 2, it helps us to understand the science and progress that further. So please take part in a science survey anytime you want independently, but we have 2 key areas of both the Biodiversity Week and the Carbon Week coming up through the summer. And we've got a sort of more monitoring training coming up. So next month in March, there's a monitoring deep dive exploring more about how tiny forests are planted and the Miyawaki method itself, so you can understand that in more depth, and then also how to engage your local schools. And finally, we'd love to say, thank you so much for all of your hard work and your help. Honestly, we couldn't do any of this without you. Citizen science is so important, both for empowering people to look after their green spaces and get connected to nature, but also providing us with the science that we just wouldn't be able to do by ourselves. So thank you for being here. Thank you for all your hard work and for the hopefully forthcoming monitoring. And apologies we've run over, but let us know if you have any questions. I'm just checking the chat. Yes, there are. There's just Alexander saying how many benefits there are from the tiny forest. It's unbelievable, and we haven't even covered probably half of the things that we could do. Caroline, you've got your hand up. Do you want to shout out?
Yes, I was just wondering how you're going to fund this very long-term research, because it strikes me that you're going to have to keep doing this for about 20 years for each forest.
Yes.
We'd love to do it.
And how are you going to be able to make that happen? Because I guess my understanding is that the funders, really funding the planting. Have you managed to get things in place to be able to do this science really long term?
It's an ongoing effort. So we are building supporters who have come initially, the sort of funders and corporate bodies who have initially come in because they want to plant a tiny forest, who kind of got caught up in the process. So there's a few conversations going on at the moment about funders more long term for the science, also through major donors and philanthropy side of funding. That's what's funding some of my time on the Miyawaki Research Network, trying to get other researchers involved. So yeah, it's a very important point you raise. It's definitely an ongoing effort, because we obviously need to have the resources and the infrastructure and the support to support any citizen science program needs ongoing engagement and training and resources. The other side of it is that with every forest that's planted, there is a proportion of money to support the team that does all the supporting and all the infrastructure in the background. So with more forests being planted, yes, there's more outlay, but the infrastructure of the portal and the resources is funded in a sort of piecemeal way, in that way, to keep supporting us. Yeah. Thanks,
it's also
Caroline.
worth mentioning, Caroline, that another project within Earthwatch, Freshwater Watch, has been going for 10 years. So as a citizen science monitoring programme with great success. So we'd like to do similar, and as Daniel said, we'll sort of be following various avenues to hopefully turning this into what's known as a long-term ecological experiment.
Yeah.
Yeah.
Daniel.
Yeah.
Oh, hey guys. Yeah, thanks a lot. I'm brand new, so I haven't done any monitoring myself as yet, but
Welcome.
yeah, I'm studying ecology right now, and I'm coming into just finishing my 3rd year in the next couple of months, and I'm pretty inspired by this and the whole technique, and I was kind of curious as to the potential to maybe incorporate it into a potential dissertation project, to kind of like work together with you guys potentially. Where would be the
great.
best place to go to kind of find out about that network that you talked about and things like that?
We'd be really excited to have a talk with you about that. So
okay.
I'll pop my email in the chat and just give us a shout. We've worked with students over the last couple of years at undergraduate and postgraduate level in their dissertation or volunteering opportunities. So please do get in touch and let us know what your ideas are and where you're based.
Amazing.
There's all sorts of ways to get
cool.
involved.
I'm in Glasgow. I've just signed up to the one in Queen's Park Recreation Ground, actually. So I'm really close to that one.
And Glasgow is great because there's actually multiple forests. So for a student project, it's the most interesting that you can visit more than one forest.
That's what I was
Glasgow's
thinking.
Based for that. So yeah.
Amazing.
Yeah. It's a great opportunity for us to explore in depth a few more of these questions in a way we wouldn't otherwise be able to do. So yeah, very keen to have a chat with you about that. Daniel, Karen has a question in the chat which you might be able to answer. So she said, regarding the wild garlic and butterflies, is it advised to plant wild garlic near or inside the tiny forest?
Great question, Karen. At the moment, we haven't advocated planting in the forest. We know that planting in the forest happens, and we know that things will naturally appear in the forest. At the moment, it's more advised to add habitats in the sort of immediate vicinity of. So if you were to want to do some wildflower planting around the forest, that would be absolutely brilliant. And we could certainly give some tips on what might be suitable, or if you could give us a bit more information what else is in the park or in the land surrounding the forest, so we could understand that. It does raise a question that we've been trying to tackle internally of how do we know when things like this have been done. So we've been talking about tracking changes. So obviously we suddenly saw a surge in butterfly species in your forest. It would be great. We'd need to know that a particular intervention had been taken. So it'd be really interesting if groups want to do things like that, and it'd be really lovely to hear about it and what you found might have worked or otherwise. We have got some forests that have already, when they were planted, were part of a wider scheme where some wildflower planting was carried out. So yeah, if you want to pursue something like that, please do.
Yeah, that'd be great, because ultimately we can't tell you exactly what to do with these sites. They are community resources, and all we can do is advise in terms of maybe what we would do or what a natural forest would do. So a natural forest, it's called succession. We just trying to let it naturally evolve its populations, be it plant, animal, etc., in its own way. But understandably, because it's a community resource, some people do want to put things in there, be it a wildflower meadow or different tree species, and that's fine. It just helps us understand. If people can let us know, it helps us understand any sort of unusual results we might get. Yes, please, we're on a school site, so broadleaf native trees. We would like to have wildflowers nearby. Fantastic.
Perfect.
Well, if you want to, Daniel, should she either contact Divya or one of us about maybe implementing?
Probably go to Divya. We can signpost some resources to you, and maybe link you up with the schools team, because they're doing another project with some schools not related to tiny forests, that's doing other green, if a school can't house a tiny forest, maybe they don't have space, and I think some of those other projects involve some wildflower planting, so we've probably got some bespoke school resources coming out soon. So yeah, I'd get in touch with Divya about it, Karen, if I were you, and she can always pass it on to us if she needs some assistance.
Yeah, and if you want some good resources for example, wildflower mixes, because some of the ones that they advertise, for example, in supermarkets, etc., they're actually sort of arable field mixes, such as poppies and cornflowers. If you want a true sort of grassland meadow, there's a charity called Plant Life. They provide fantastic resources on planting your own wildflower meadow, and also the best places to buy seed mixes. So if you go and have a look at their websites, I think they've Magnificent Meadows is one of their hubs that is specifically on that, and you can find out the best way to do that and the best place to buy seed mixes for that purpose. Bro, Divya's been in touch about your sign. Brilliant. Okay, so you've already got her email. That's great. I hope that's been useful. Is there anybody else that's got any? Caroline?
Sorry, another question, if that's okay.
No, it's fine.
One of the things I'm hoping the science can help with is thinking about different kinds of sites. So in my London borough in Lewisham, both tiny forests have gone into parks, which is a fine place to start. But what I'd really like to do is plant them in industrial estates and retail parks. I think that's where this should go, onto kind of brownfield sites. Obviously, it's much more challenging, not only the planting, but also convincing local people that that's really what we should be doing. And I think what would really help is some science and some case studies that show that these kind of plantings can work on industrial estates.
In that kind of.
Have you got any sites like that, and are you going to be able to produce some data that shows that it can work and the benefits? Because that's going to really help to spread it into these more challenging sites.
You're absolutely right, Caroline.
Yeah. So what I'm currently sorry, Daniel.
Go for it.
So Daniel will be able to answer about industrial sites. I'm not exactly sure on that one, but certainly about these more challenging brownfield sites. I'm currently involved with one of our tiny forest planting projects that's just in the planning phases at the moment, which is actually on an old landfill site. So that's a particularly interesting, unusual one, because they can't use it for allotments, they can't use it for house building, but we have done sampling there. It is safe for something like this. So we're working very closely with the project planners to make sure that's done in the correct way, and we'll hopefully use that, like you say, the research specifically from that to support planting in other areas such as this. And this sort of the donors and the owners of the site are really interested in supporting the science, so that can contribute for sort of research and regeneration of those sort of areas that are quite difficult.
Yeah, the main barrier for other industrial or sealed surfaces, as a phrase, is cost. So we don't have many. I think there's one coming across the line that Jane, our land manager, has fought very, very hard for. But the funders, the amount that it adds on to the cost of removing any of the hardcore has been prohibitive thus far. So as they come on course, we would definitely seek to make sure that the data collected there is sufficient, and maybe do something extra through some sort of research partnership to make sure that we can use that as a really good test case, because we're not going to immediately have a sample size of even 5 very rapidly. But I think it's worth it's coming in more into public consciousness, the importance to removing unused sealed surfaces and concrete. So hopefully the opportunities will only increase, but it's a really important point, and it is exactly where something like a tiny forest should be.
and hopefully removing car parking and replacing it with trees on these vast areas in urban landscape, which are just hard surfaced, and the car parking, which really we need to be moving beyond. But it's getting the evidence, because I haven't even dared raise it locally, because I think nobody's going to go there until we've got some proven case studies that
I know it's going to be a bit of a long game, I think.
They've done it in the US, haven't they? I've seen some pictures of actually a quite beautiful retail estate in America, where they've planted like this, and then it looks like somewhere you might actually want to go, because it's there's so much shade, and the buildings are cool, and the whole thing's protected from wind and extreme weather. It actually, I think you could sell it if you could.
I think so.
They do exist. It's so my partner works in these as an engineer in these what's called massive sheds, they're called, even though they're far beyond sheds, they're huge. And a lot of these companies do their own initiatives in-house, where, you know, but the thing is that they're not part of something like we have here, where they're monitoring the benefits. The JCB, for example, always try and take, especially when they're near to a community. So they have a site in near Alton Towers in the Peak District, and they've done amazing work with regreening around the edges of the site, both for staff welfare, so they can go for a nice walk at lunchtime, but also for the local community. So you do get this happening, but it's kept very in-house with the companies themselves. And I totally agree, you know, if we had something that was actually monitored and we were able to either formally publish in a journal or even just give practitioner guidance, you know, that's something more grey literature, that would be super helpful. So it's just maybe getting in with the right people.
Lots of the tools that we develop for tiny forests could be used in another habitat. So our monitoring protocols and citizen science could be used elsewhere. So if we found an opportunity that even wasn't one we were delivering, but we could find a way to resource engaging people to monitor it, then that would give us a really interesting, you know, comparison using the same protocols. So yeah, it's in the thinking, but yeah, thanks very much, Caroline.
Yeah,
right.
The ambition is admirable, both from our team and everybody who's here. It's just really wonderful.
I'd like to see it go in the planning process, so that these they create these things or upgrade them, they are obliged to do this kind of planting.
Yeah,
there's no reason.
There is more and more of that now with the
new
the government environment plan and the biodiversity net gain protocols. Means there's more that is being enforced. You know, pros and cons of the ways it goes about and how it's actually regulated, but it's certainly more than it was when I was working in planning 20 years ago.
It used to be optional, and it will be mandatory.
Yeah.
So
in the right direction.
Yeah. Cool. Brilliant.
Right. Thank you all so much. I think we'll probably call it a night and let you all get to your tea or whatever you're doing. Really appreciate your time and questions, and yeah, look forward to seeing you on a tiny forest site somewhere soon, even if not in person, virtually.
John, we'll see you in Dublin.
Yes, see you in Dublin, John.
Are you both coming over?
We are, bizarrely.
Okay, both of you. So okay, looking forward to seeing you.
We both live in North Wales, so we're the nearest people to come and.
All right.
So
okay.
Yeah.
I have some heavy duty soil testing equipment you can take back with you.
Oh, lucky us.
That would be great though. Okay, brilliant. Like, thanks so much everyone for being here. And,
thank you.
Take care.
Thanks, everyone.
Bye-bye.
Thanks a lot.
Thank you.